Hello everyone, so in this video we will be doing about a question on binary search. So this is the second part of the video, and from here on we will start doing the questions. So in this video we will be doing this question, that is search a 2D matrix. So what we have to do is, like, we are given a matrix of m cross n size, right, and we are also given a target value. So what we have to do is we have to search for this target value in my matrix, and the integer in each row are in sorted order. So this, like, 1 3 5 7 10 11 16 20, and all these rows are in sorted order, and the first element of each row is greater than the last integer of the previous row. So this 7, right, I have this 7, so this 10 will always be greater than 7, this 23 will always be greater than 20. So, like, this element will be smaller than this one. So let us just take this example. Let us suppose I have this matrix, right, and the values are 1 3 5 7 10 13 21 22 25 29 33 and 40, right. So, like, this 7 will always be smaller than this 10, and these rows are always sorted. So in how we can do this question? So, like, what I can do is I can just traverse my matrix and find for the target. So for example, my target I want to search for is 21. So what I can do is I can just traverse this matrix, like I can go to 1 3 5 7, like each particular element, and check whether it is equal to the target. So this is the one way I can do, and in this I will be traversing my whole matrix. So the time complexity for this one will be n cross m. Another way is, like, what I can do is I can store all these values in an array, and then I can apply a binary search, right. I can store all these, like 1 3 5 7 10 13, so on up to 40. Then this will be low, this will be high, and then I will apply the binary search. So first I will traverse n into m, then a binary search of log n plus m, right, and also I will be using a space of n plus m. So this is another approach. So what I can do is, another approach is I can apply binary search on each of these rows, right. I can, like, traverse for I equals to 0, I less than n, where n is the number of rows, I plus plus. Then I'll call the binary search and I'll apply binary search on each row and check for this. So this one will be a n log m approach, right. So these are the three approaches. Now the best approach, what we can do is, how can I apply a binary search on this complete matrix? Since I know it will be sorted like this, 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 and like this. So if I go in this order, so it will be something like this, sorted like this from here to here. Then if I go from, then it will be sorted like this, and it will be sorted like this, right. So if I number these, right, this is my element 0, element 1, element 2, element 3, element 4 5 6 7 8 9 10 11. Okay, and the target here is 22, right. So how I can apply the binary search? I'll take my low as 0, and what is high? High will be 11. So high is 11. How is high taken? High is n into m minus 1, right. So my mid will be, what will be the mid? Mid will be 11 plus 0 by 2, which will give me 5, right. So I want this index. So what is this index? It is mid divided by m and mid mod m. This is my I, this is my j. So mid is 5. 5 divided by m is 4. 5 divided by 4 will give me 1, and 5 mod 4 will also give me 1. 0 1 2 0 1 2 3. So this is my 1 1, right. So element is 12. So at this index my element is 12. So I see, okay, 22 is greater. Let's move ahead, and this time my low will be 6, and my high will be again 11. So mid this time will be 17 divided by 2, which will give me 8, right. Now again I will apply this formula for I equals to a, mid is 8, 8 divided by 4, and j will be 8 mod 4, which will give me 2 and 0. So at 2 0 I have 19. Since the value is 22 is again greater, I'll change my low. Low will be this time, last time it was 8, so low will be 9 and high will be 11. Now this time my mid will be 20 plus 2, which will be 10, and if I calculate my I will be 10 mod m, 10 divided by m, that is 4, which will give me 2, and this one will be 10 mod 4, which will give me again a 2. So I will look at this matrix of 2 2. 2 2 is 25, so it is 25, so it is greater. I'll decrease my high, so it will be this, and high will again be 9, so it will be 9 plus 9 more divided by 2, which will be 9 again, and I will be 9 mod 9 divided by 4, which will give me 2, and j will be 9 mod 4, which will give me a 1, right? So 9, and this will be my 22 value, right? So this way I can do this in a time complexity of log n plus m, right? So let us just code it instead of writing the pseudocode. Let's just code. So it is, let me take this as matrix and this one as target. So what do I need? I need size, n is equal to mat dot size, int m equals to mat of 0 dot size. So this gives me column size and this gives me row size, right? And now I need my low, which will be equal to 0, and my high will be n into m minus 1. So while my low is less than equal to high, typical binary search algorithm, int mid equals to low plus high divided by 2, and if my, okay, I need to calculate I and j. I is equal to mid divided by m, and int j is equal to mid mod m, right? If mat of I j is equal to target, I'll return a true, else if mat of ij, okay, so like here we are repeating mat of ij and mat of ij, so there is a concept of dry, that is don't repeat yourself in coding. So what I can do is int value is equal to mat of ij, and now I will use this value to compare, so I don't repeat my code over and over again. So if mat of ij, instead if value is less than target, my low will increase, low is equal to mid plus 1, else high equals to mid minus 1, right? And if I don't find any value, I'll just return a false in the end. So let us just submit this. As you can see, it is working absolutely fine, and if we just have a look, so this was the code, and the time complexity is O of n plus m, where n is the size number of rows and m is the number of columns. Do like the video and do subscribe to the channel, and in the next video we will be doing another question on LeetCode related to binary search. So thank you for watching the video.